In this tutorial, I will be solving three problems, and the first is related to finding the voltage generated or the armature voltage or generated voltage based on the voltage equation, and type of armature winding. So this is a question 1, and so the equation for the voltage generated is given by Eg is equal to phi Z N P divided by 60, and it is P by A volts. So the first question is, there is a shunt generator which has 4 poles, and the armature conductor Z is equal to 800, the N is equal to 1000 RPM, and the flux per pole is equal to 30 milliweber. So how to calculate the Eg? So, and the 800 conductors are wound in a wave winding. So the Eg is equal to, in this case, equal to 30 into 10 raised to minus 3 into Z, which is equal to 800, into number of RPM, which is equal to 1000, divided by 60. Now into P by A, the number of poles is equal to 4, and A is equal to 2 in case of a wave winding. So if there is a wave winding, the number of parallel paths is equal to 2, which is given by A. A is equal to number of parallel path is equal to 2. So which is given by 30 into 10 raised to minus 3 into 800 into 1000 divided by 60 into 2. So 30 into 800 into 1000 divided by 60 divided by 1000 into 2. So this is equal to 800 volts. So this was my first question, which was based on the wave winding. So now there is a same question, everything is same for it, but the 800 conductors, the question 2 is again for a shunt generator. Everything is same, but same as question 1, but the 800 Z is equal to 800 is in a lap winding now. So now Z is equal to 800 divided by 2, which is equal to 400. Or for a lap winding, A is equal to P. So this is wrong. So this equation again, it will become Eg is equal to 30 into 10 raised to minus 3 into 800 into 1000 divided by 60. This whole thing will cancel because A is equal to P, because this will cancel. So now the voltage generated in that case will be close to 1600 volts, which is double of what it was being produced here. So this was the first and the second problem which I want to solve, and it was related to how to calculate the generated voltage based on the voltage equation of a generator. This is a voltage equation of generator, or so based on the voltage equation of DC generator, how it is possible to calculate whether it's a based on whether it's a wave winding or whether it's a lap winding. Now the question 3 is related to a separately excited generator. So there is a separately excited generator, and this is rated at 25 kilowatt, and the resistance of the armature is 0.05 ohm, and the brush contact drop is 2 volt, and the rated voltage is 230 volt. Now the question is to find the generated voltage of the armature, EG or EA. So based on the question, it's possible to draw the circuit diagram for a separately excited generator as this way. So this is my RA, which is equal to 0.05 ohm, and this is my plus or minus, and this is my EG, which is being generated, and minus or plus you will be having your EB, which is equal to 2 volt. So that is a brush contact drop, and this is my voltage which is rated, which is equal to 230 volt. Then this is my load current is equal to armature current, and there will be the field here which can be shown like this, which is supplied by a DC source, and which is a variable field, and the field current is IF. But in case of a secondary, or in case of a separately excited generator, the field current and the voltage is nowhere related to my generated when I am calculating the EG based on what is my load current. So the field current will not affect the load current here in this when you are calculating it in this way, but when you are calculating it based on the EG is equal to 5 ZNP into 60P divided by A. In this case the flux will be related to what is my field current. So in this equation there will be some relation, but in this case we are assuming that the field IF is equal to constant here. So based on this it can be found out that EG is equal to V plus EB plus IARA, which is equal to 230 plus 2 plus my IA is equal to my 25 into 10 raised to 3 divided by 230, which comes out close to 108.69, and which is 108.69 into RA, which is equal to 0.05. So this is equal to 230 plus 2 plus 108.69 into 0.05, so which is equal to 237.434, which is equal to 237.434. So this is what is my EG, which is a generated voltage. And so that was how to calculate for a separately excited generator. So that was a third problem which I solved as part of this tutorial.